21.4 temperature. The normal human body temperature is 37.5 degrees, and if the temperature increases, the person will suffer from severe hyperthermia. However, if the temperature goes too low, the person will then suffer from hypothermia. So homeostasis. This is the process that the body uses to maintain a constant internal environment. It's in charge of regulating body temperature, carbon dioxide, excuse me, the pH of the blood, the glucose levels in the blood as well, and the water balance. To regulate all of these factors, there will be a stimulus that the body sensors will detect. Once the sensors have picked up on the stimulus, then the body will activate a certain area of the body to help deal with this. The body will then deal with the stimulus, and the body will return to its normal state. So, for example, to control the glucose levels within the body, if glucose levels are too low, so this will be the stimulus, then the cells in the pancreas will detect this, so this will be the sensor. The pancreas's cells are stimulated so that they will release glucagon into the blood. This glucagon goes to the liver. The liver will then break down the glycogen stores to release glucose back into the blood. This will then get the glucose levels back up to normal. However, if glucose levels are too high, so this will be the stimulus, then other cells in the pancreas will detect this, so this will be the sensor. The pancreas's cells are stimulated so that they release insulin into the blood. This insulin goes to the liver. The liver will then store the excess glucose, resulting in a decreased level in the blood. So this will return the glucose levels in the blood back to normal. So thermoregulation is the body's ability to keep the temperature at a certain temperature. If the temperature gets too high or too low, there are ways that the body will control this. So if the body's temperature drops, then the body will detect this, and the blood vessels will constrict around the surface, so this is known as vasoconstriction, and this will conserve the heat. The muscles will also contract involuntarily, so this is known as shivering, which will produce heat to warm the body up. The body will then return back to normal. However, if the body temperature increases, then the body will detect this, and the blood vessels around the surface of the body will dilate, so that heat is lost. So this is known as vasodilation. The sweat glands will also produce more fluid, so this fluid will evaporate on the skin, which causes heat loss, as it will take away the heat energy from the body. The body will then return back to normal level. So the effects on the body of high temperature. So as the temperature increases, the body will heat up. When the body's thermoregulation begins to stop working and the body's temperature increases, the body will enter hypothermia. When you enter hyperthermia, your muscular endurance will decrease, as your body will be using more energy on other things, so then there isn't as much energy for your muscles to work. The body will also become dehydrated, which will lead to the thickening of the blood. This makes it harder for the heart to pump it round, so the heart will have to work harder, meaning that the heart rate will also increase. More energy will be used to pump the heart, and therefore won't be used for the muscles that are trying to work, so they will tire out quicker. To cool yourself down, your body will go through voluntary and involuntary responses. The involuntary responses include vasodilation of the blood cells. This allows more blood to circulate through the blood vessels with more ease, meaning they can get to the skin so that heat can evaporate out of the body. Another involuntary response is sweating. This is when the body loses water by evaporation from the skin. Whilst this happens, it will cool the body down, as it takes away the heat energy from the body. Voluntary responses will include placing things on your skin to cool you down. This could be a cool object such as a cold water bottle or flannel. You can also cool yourself down by removing items of clothing. Effects of low temperature. As the temperature decreases, the body will cool down. When the body's thermoregulation begins to stop working and the body's temperature decreases, the body will enter hypothermia. Hypothermia is linked with high blood pressure, rapid breathing and constricted blood vessels, as well as lack of coordination and fatigue. When you enter hypothermia, the muscles in the body will start to get tighter and will seize up. This is due to the loss of heat, making the muscles not as pliable. There will also be vasoconstriction occurring in the blood vessels, as the blood will be kept around the core to keep that warm, so that the organs in the body don't shut down. If vasoconstriction occurs in the limbs, then the body won't be getting enough oxygenated blood, so won't be able to respire aerobically, meaning that the muscles won't have enough energy to work, which will then have a negative effect on performance. There will also be an increased heart rate, as the body will be pumping oxygen around to try and keep the body warm, so the heart pumps around blood quicker to keep it warm. To help warm the body up, as well as the body will go through voluntary as well as involuntary responses. So the involuntary responses involve vasoconstriction of the blood vessels at the surface of the skin. This will restrict the blood flow and prevent heat from leaving the body. Your hairs will also stand up and cause goosebumps on the surface of the skin. This will cause a non-smooth surface, meaning that the heat will be trapped and won't leave the body. Whereas the voluntary responses include the athlete adding stuff to themselves to warm up. So this will include adding layers of clothing, or they could voluntarily contract their muscles. So with the test, so the method, the way we test the effects of temperature on the body, we tested this by controlling the temperature that was exposed to the participants. So we had 10 minutes resting in a regular condition, which would have been controlled. Then 10 minutes submerged in an ice bath. This is the first stage of cooling the participants. Then the participants will wear an ice vest, which is another form of cooling them down. The athletes will then cycle for 10 minutes at a resistance of 70 RPM. So results. In the results above, we can see that the heart rate during exercise without cooling is much higher than that of using the ice bath and that of an ice vest. When the participants use the ice bath and the vest, they will be slowing down their heart rate due to vasoconstriction, as the heart will only be pumping blood to the core muscles and organs. These areas are close to the heart, so it won't have to be pumping that much blood to far away distances. When you don't pre-cool your body, your heart rate will increase. This is because vasoconstriction isn't taking place. The RPE when exercising with heat compared to normal temperatures is much higher. This is because the fluid inside your body is leaving due to sweating. However, you need water in your system for your body to function properly. If you get dehydrated, it's harder for the heart to pump around the body, so the body has to work harder to get the blood round. This means that the body will get fatigued more quickly, therefore the RPE will be higher than that at normal temperatures.